So welcome to Feature Fridays. My name is Guy Bartram, Director of Product Marketing at VMware, and I'm joined today again by Gerrit, Stefan, and Jörg for, I think this is episode 5 or 6 in the mini-series of Tanzu. So chaps, let's have a quick introduction. Gerrit, why don't you go first?
Sure, thanks, Guy. As always, Gerrit there, Cloud Solution Strategist in the Worldwide Multi-Cloud Architecture and Strategy team.
Thanks, Gerrit. And Stefan?
Cool. Thanks a lot, Guy. In the meantime, maybe you should know me already. Stefan Berner, Lead Solution Architect for VCPP, focusing on modern application technologies.
Thanks, Stefan. And Jörg?
Yeah, Jörg Liff, Technical Product Manager in VMware's Cloud Provider team.
It actually sounds the same when everyone says it as the last time. It's incredible. I think we say the same words as well. Anyhow, welcome, guys. Thanks for dropping in today for, I think this is probably one of the, getting to the end of the Tanzu mini-series now. There'll probably be 1 or 2 more after this. But today we want to focus on the developer and talk about what the developer would need in terms of CI/CD and how Tanzu can work with a developer pipeline. And cover things like application catalogs, the frameworks, perhaps tooling that's available to them. So, Gerrit, I know you had a slide or 2 to start us off with. Do you want to dive straight into it?
Yeah, sure. Let me share my screen quickly. There we go. So when we look at, the Tanzu umbrella portfolio, there are all those products in here. And in previous sessions, we did cover Tanzu Basic, as in TKGM and TKGS. And we also covered Tanzu Standard, as in TKG and TMC, right?
Yep.
So today is really more about what's all contained in the upcoming Tanzu Advanced Edition, which is really, Tanzu Build Service, Data Service, Application Catalog, Service Mesh, and Observability, which then in combination with all those other products allows our providers to focus more on DevOps as a service towards their customers and especially towards their customers' developers. So DevOps meaning that, we want to bring together the development part of the house where, developers are coding, building, testing new software functionality, and then the ops part of the environment, releasing it, deploying it, operating the whole stack, monitoring it, and reporting back into the next plan phase so that this all works smoothly together. So this is really the set of capabilities that we want to enable and support with the Tanzu Advanced bundle of products. So this is going to be a pretty busy slide, but it really helped us in the past with getting people to understand where Tanzu fits in this modern application and DevOps lifecycle, and also how this relates to other products that partners might already be using and that we have in the rest of the VMware portfolio. So we start with the developer itself or himself when they are developing on a local machine. This could be a desktop or a laptop, but could also be a virtual desktop delivered by a Horizon, right? In any case, from an operational perspective, we want to make sure that that developer machine is somewhat compliant and that developers are maybe using a compliant set of tools from the organization. So this could be done via Workspace ONE. But in any case, what happens at the end of the day, the developer is going to commit their code once a day or multiple times a day or once a week or once a month or once a sprint into a code repository. And that code repository could be really whatever the developer or the organization prefers. Could be Subversion, GitHub, or in this example here, GitLab. Now, from an operational perspective, we want to ensure that this code repository is not deployed from any random source. We want to make sure that this package and software is deployed in a compliant way from a secured source. And that could, in the Tanzu world, be the Tanzu application catalog and the Bitnami community catalog. So this allows the operations side of the house to make sure that this GitLab repository and the software is deployed from a secure repository. We know that it's configured in a best practice way. And we know that there is, the same kind of version across the entire organization.
So Gerrit, just to pause you there. So what we're talking about there is a catalog that's been curated by either the service provider or the tenant admin into something like App Launchpad, where they're pulling down the VMware Marketplace images for, in this case, the code repository. Then they're able to deliver that. And that's the big advantage of that is it's tested by VMware, tested from functional testing, and security testing as well. So it's not something that's just kind of out there on the net, sort of shareware that anyone could change or whatever it is properly tested and validated before it is made available to the catalog. So then the tenant admin can choose to deploy and allow their tenant users to deploy different instances of this private repository into a secure environment in their cloud on, in this case, VCD, VCF, or VMC.
Exactly, yeah. So, and this is, the beauty of integrating the Tanzu application catalog packages or with NAMI into VCD, right? We have a predefined set of open source packages that can be used in a compliant way, and the tenant admin can deploy this via self-service into VCD or even, as I said, into VCF or VMC, right? And the developer gets quick and easy access to a compliant instance of, in this case, GitLab or whatever other source code repository they want to use.
And is there a use case where a developer would want to use the public GitLab repository over a private one? Because it seems to me if you are an organization that's self-consuming its own applications, i.e. you don't want them published publicly, then having a private repo to check in and out is a no-brainer.
Yeah, from my experience, they would usually want a private instance of this, right? So they might defer to managed services of GitLab or whatever else because they don't want to take over the operations part. But in a cloud provider setting, that's what the provider can take over, right? So that's really the best of both worlds for the end customer developer in this case.
Cool, thanks.
Okay, so now we have that code repository deployed in a secure and compliant way. What the developer really cares more about is, the continuous integration part that follows after that. So once the code is committed to that repository, it triggers the so-called continuous integration pipeline, which does multiple things like compiling, integration, unit quality testing, security scanning of the code, license dependency scanning, and so on. And there is a variety of open source tools that developers prefer and rely on for that continuous integration pipeline. So this could be Jenkins, could again be GitLab itself, JFrog Artifactory for artifact storage, really a lot of tools that customers and developers may prefer and choose here. So this is then the same logic as with the repository itself. We want to make all these open source components available from a secure repository that are being packaged in a secure and compliant way, and give customers an easy way to host them wherever they want, so VCD, VCF, or VMC. And knowing that usually there is a preference or bias towards one open source solution, we really provide the full choice here, or our providers can provide the full choice here to their customers. Now, VMware itself has tools that can create CI pipelines themselves, for example, VRA CodeStream or the Tanzu Concourse CI. So there's again the choice of open source packages or maybe VMware provided and supported tools, whatever the provider or the customer may have as a preference for the CI tooling. Now, another step in the CI pipeline is turning that code and everything else that's required into a container image that can be executed somewhere, right? And usually you would do this by creating and maintaining and updating Docker files, which at scale is pretty hard and not really sustainable. And this is where Tanzu Build Service comes in. So Tanzu Build Service is a piece of software that lives on top of any given Kubernetes cluster. For example, the TKG cluster that our customers can deploy via the VCD container service extension. Tanzu Build Service gets installed on top and monitors changes to the code repository down here. And from there, it creates and packages the Kubernetes container file, and it also maintains them, keeps them up to date in case there are code changes or library changes or the underlying operating system needs to be swapped out. So really a easy and scalable way to package and build container images and also maintain them and keep them up to date. As a result of that, we're going to store that container image somewhere, usually in a private container registry, because you don't want to, again, have this in a public repository. And in the VMware world, this would usually be the Harbor container registry, which again is available from Bitnami and Tanzu application catalog. So customers or providers can deploy this via self-service from at Launchpad to live on top of TKG or on top of VCD or really, anywhere else. So from there, we enter into the so-called continuous delivery or continuous deployment part of the DevOps lifecycle, whatever the approach here is for any given customer. And again, in that CD phase of the whole process, we have a variety of open source components that customers may prefer, right? So there's, again, GitLab, Argo CD, whatever they choose and what they may already be using today as part of their practice. And in this phase, they'll be, deploying the application to a non-production environment. They'll conduct user acceptance testing, additional testing, and then finally deploy this to production. And besides all those open source tools, which again, we can make available from Bitnami and at Launchpad in VCD, they will usually also require the underlying Kubernetes clusters for multiple phases of that CD pipeline. So this is non-production for UAT or for additional testing, as well as a separate production cluster where the application then finally lives once it's deployed into production. And this is really what we've seen in the previous sessions where we've explained how partners can offer self-service Kubernetes as a service with TKGS and TKGM, and from there allow customers to easily deploy new clusters for different purposes and stages of the development lifecycle. One thing that comes on top, and that will be required for any modern application, is data services. So you'll usually need different forms of databases, whether that's SQL or NoSQL, caching services, message queues for inter-service communication, as well as maybe data warehouses and so on. And for that, we have two approaches in the Tanzu world. We can let our customers deploy these Postgres, MySQL, RabbitMQ, and so on components from the Bitnami catalog via App Launchpad, and then handle all the operations themselves, like scaling, high availability, backup, and so on. Or our customers and partners, for that matter, can rely on the so-called Tanzu data services. So these are really, more enterprise-ready and on-demand implementations of these open source products, which allow customers to then deploy a high available RabbitMQ stack for message queuing, or Tanzu Greenplum as a data warehouse, or Tanzu SQL as a MySQL and Postgres implementation that is already high available, scalable, and including best practices and backup and so on. So this is something that would, again, live on top of a Kubernetes cluster or on top of VCD when it's deployed in virtual machines, right? And then the last aspect of this CD pipeline is really the GitOps approach to deploying the underlying infrastructure and managing it via things like infrastructure as code or configuration management. So in the VCD world, this could be done largely via Terraform, but customers could also choose to layer vRealize automation, including SaltStack on top, to make sure that the underlying infrastructure, including all the services that are required to run the code, are handled in a similar way as the code itself, meaning via pipelines, via infrastructure as code, and via repositories. So now there's still a couple more considerations. One of them being security, compliance, and policy management of those underlying Kubernetes clusters. And we covered that in the TMC session last time, right? So we can use Tanzu Mission Control to enforce policies across these various Kubernetes clusters. And for example, if we want to do backup and data protection of those Kubernetes workloads, we can use the VCD object storage extension in combination with Velero. And then again, from the service provider world, we'll also need to take into consideration disaster recovery protection of those, especially the production clusters that we have underneath. Again, a very operational centric view on the whole pipeline, but a very important thing to consider. And for that, we can use VMware Cloud Director availability if we're talking multi-tenancy with VCD, or Site Recovery Manager if we're talking about a dedicated environment, or maybe even VMware Cloud. So what this leads us to is, the whole application package being integrated and deployed into a production cluster down here. And from there, if we want to, conclude the whole DevOps lifecycle, we move into the last phase, which is continuous monitoring. And again, a very operation-centric view on the whole big picture. So for continuous monitoring, we have various tools looking at various layers of those modern application stacks. So first of all, there's Tanzu Observability, which is our end-to-end full-stack monitoring and observability tool, which can take information, from the application itself, from the underlying cloud infrastructure, from all these services in the pipeline, and correlate these informations to make troubleshooting and observability actually doable in the first place for those highly distributed and complex modern apps. And the second part from the Tanzu portfolio itself is Tanzu Service Mesh, which is our enterprise implementation of the Istio open source service mesh, and is really meant to decouple the communication of microservices from the underlying network and infrastructure. So we can implement things like circuit breaking or encryption between microservices without really needing to understand what the underlying network looks like, and without having to implement those features in the software itself. So the service mesh is sort of a layer in between that takes care of all of these complex communication patterns and aspects in the microservices world. Now, besides those two Tanzu products, there are more monitoring tools that may play a role in this, one of them being Cloud Health. So parts of these pipeline may live in a public cloud environment, right? So VMware Cloud or native Azure or native AWS. And Cloud Health can then, as a SaaS service, help us operate and optimize these native public cloud environments by providing cost optimization or governance and compliance. And then, of course, for many providers, they're already invested in the vRealize Operations Suite, which can also be used to monitor at least certain parts of this pipeline. So whether it's the infrastructure, Kubernetes itself, as well as some of these data services that may sit on top here, especially through the True Visibility Suite, which is a set of management packs on top of the Realize Operations. And then as a last option, customers or partners may have a preference towards any given open source solution like Prometheus, Grafana, Fluentbit, and so on. So this is also an option that our partners can offer towards their customers, especially if there's already a degree of knowledge and investment in those tools. And partially, those will even be best effort supported by VMware as part of the Tanzu editions and the whole Tanzu package. Now, depending on the choice, these could again either be hosted on-prem, if it's a sovereign cloud, for example, in the VCD environment, or could be delivered as SaaS services, for example, Cloud Health, TSM, and TO are SaaS services in and of itself. For VROPS, we have the full choice of on-prem or VROPS cloud, depending on what the customer's or partner strategy is there. That's it for the big picture. I know it's a busy slide, but I hope this helps put into perspective how this all fits together in the VMware world.
Yeah, it certainly does from my perspective. There's a couple of things I want to, and a couple of areas I'm not quite clear on 100%. So essentially, when we're looking at the development, we start at the top left, the development, the code, the commit into the repo, the continuous integration, all of the packages that may be used there are obtainable from our VMware marketplace and can be delivered by App Launchpad. And then we have things like VRA CodeStream and Concourse CI, which I don't know where Concourse comes from. I don't think that's on the marketplace, but
it is actually.
It is.
It's gotten in through Bitnami, I think 1 or 2 months ago. Yeah, so there's a publish for that yet.
Cool. And then we're into the kind of Tanzu stuff. Again, this is obviously something that's delivered, with Tanzu. And we move into the continuous delivery and continuous deployment phases. Again, those OSS packages, they could be delivered by App Launchpad if they're available on the marketplace, or they could be delivered by custom third-party ISVs for App Launchpad or custom applications as well. So a lot of this is really the ability to deliver the right applications for the developers, what they're comfortable with and using. So my question is, can you tell me about the life cycle of those packages? Because obviously, these software services, which are free online, most of them, they're going to go through different iterations, different versions constantly. How do we ensure as a service provider that they're using the latest version of Git repository or Jenkins or something like that, and they're not exposed by maybe a security flaw in that solution that has been preceded by another version of that software online?
Mm-hmm. Yeah, I mean, the first step to this is, making the newest versions available as part of the catalog, right? And Bitnami, for example, does that automatically. So it'll, build new packages and publish them continuously via VMware Marketplace, which will then, push them down into the service provider catalog. The second part is then how does the provider make sure that the instances that are already deployed in the customer's environment are actually updated and rolled out to the newest version. So this depends on the degree of managed services that providers put on top. So this could be the customer's responsibility, as it usually would, right? Or you could provide a managed service where the provider actually takes care of this and then leverage various tools to actually, deploy new versions or do rolling upgrades of that. For example, native Kubernetes functionalities for upgrading deployments on Kubernetes. So, removing existing instances with newer versions, or using things like QApps, which actually has this rolling upgrade feature out of the box. So depends on whether that's the provider's responsibility or whether we leave that up to the customer themselves.
And then coming down to the Kubernetes images, to the Docker images, application catalog will do security scanning and dependency scanning as well, and will ensure that your base Kubernetes images are up to date.
Okay, that's handy. All right. Yeah, so what I'm trying to understand, and I think now in ALP 2.1, it's not a push from the marketplace to the catalog, it's actually a pull. So it's I think that was one of the big changes that people were after from a communications and security perspective. Mm-hmm. But you also get to choose a certain number of versions that you want to keep. So you go for GitLab, I think you can, I don't know, 1.0 all the way through to 1.5 if you want to in the catalog and keep those running. But fundamentally, the upgrade of that is something that's not automated from our side. It could be automated by the tenant if they wished. We just make the versions available, right?
Yeah, so that's something in App Launchpad. As a service provider, you can subscribe to different catalog items, and then automatically App Launchpad will keep the local catalog up to date. But for the updates of existing, already deployed infrastructure, that of course heavily depends on the component itself. So typically, if it's some stateless component, you just can quite easily switch and update the version. If it's some stateful component, of course, there might be some upgrade or migration procedures necessary to go between different versions. That typically does not apply for small security patches, but if you go from between major versions of the underlying infrastructure, then there might be some migration effort in there. And I think Gerrit already mentioned that, just to clarify that, we have to distinguish here between components that are being used as by the tenant developer as part of their application, and they they pull the component as part of their continuous integration pipeline. Then that's something that just these updates will typically just go along with a new deployment, a new iteration of the overall deployment, because then you deploy the new version of the application, and during that deployment, during the continuous integration phase, based on the dependency checking and the compilation, the new packages will be pulled and become part of that image, Kubernetes or Docker image, that then gets deployed. On the other hand, if it's a service that is managed by the service provider and just consumed by the tenant as part of their application, then of course it's the provider's responsibility to keep them up to date. And that's mainly for components that are stateful. And these are mainly components that are part of the Tanzu data services. And that's where the lifecycle management that comes with Tanzu data services comes in, to help the provider keep these infrastructure components that they offer as a service up to date.
Yeah, that's one of the next areas I wanted to dive into. So I'm pretty clear on the application catalog now. That's been kind of our bread and butter for a long time. Can you tell me a little bit more about the data services and how the data services operates, because I'm seeing their applications that, some of those applications are also available in our application catalog. So I'm trying to understand what is the difference between the data services and the catalog.
Yeah, so I'll start, and one of the others can obviously chime in here. So first of all, Tanzu data service, they all use underlying open source components, right? But we actually take these open source components and turn them into more complete enterprise-ready products on top, if you so wish, right? So in Tanzu data service, we have Tanzu Greenplum, which is our highly or massively parallel data warehouse, and that's based on the Apache Geode project, right? Okay. Then we have Tanzu RabbitMQ, which is, as the name says, based on the open source RabbitMQ. We have Tanzu SQL, which is based on Postgres or MySQL, so both is available. And the last one is Tanzu Gemfire, which is based on, I want to say, Redis as a caching and in-memory database NoSQL solution. And instead of deploying those open source packages from whatever source, Tanzu Data Services really, takes care of a lot of the day two aspects of deploying and running these services. So you don't need to handle the whole clustering and scaling and best practice configuration aspect of setting up these different services like message queues or databases or data warehouses. So with Tanzu Data Services, it's really more of an on-demand experience and easier to consume these services, especially as part of the pipeline, right? So all of these Tanzu Data Services come with so-called Kubernetes operators, meaning that a developer does not really need to go ahead and set these databases up and install them manually. They can simply request a service in their Kubernetes definition file, right? Mm-hmm. So we'll basically expand the Kubernetes API through these operators so that developers can simply declare what kind of service they want from Tanzu Data Service, and it'll then automatically be provisioned for them, which makes it way easier to get access to these services, but also to lifecycle manage the whole thing as we iterate with new versions and deploy new versions of the application.
Right, that makes sense. So as a developer then, in terms of my production deployment, I may require a SQL server to be deployed as, and basically I'm going to write in my specification to call that SQL service in the Kubernetes specification, and it's going to then go and talk to Tanzu Data Services and deliver that for me.
Yeah, exactly.
Okay.
And obviously, I mean, there is as Jörg said, a statefulness to this, especially when we're talking about databases, right? So we need to obviously handle, what's happening with the data that's inside that service. But the consumption of the service itself is very, straightforward and implemented in a very Kubernetes-centric way, right? Through those operators and custom resource definitions.
Yeah, that's the part I'm trying to get my head around, because the application that I'm building is going to have multiple components to it. One of those may be a database, and you're delivering me the database via Tanzu Data Services. I'm just going to call for that database to be deployed. That's probably only going to be deployed once, and then from that point on, I will be iterating the application within the application server or whatever it might be, but the data structure should stay the same until I need to upgrade because there's a new release out and I'm going out of support or whatever it might be for that. So this, in my mind, that Tanzu Data Services, when you're talking about stateful applications, they're going to be, the upgrade cycle is going to be a lot slower than stateless applications where you could just overwrite and call it again with a new later version.
Yeah, probably.
Yeah, so important to understand is that the again, for typically the production environment, that where Tanzu Data Services are like managed services by the provider, the application consumes them, and this consumption is defined in the application, like the requirements definition of the Kubernetes application. And in these requirements definitions, typically there are some information about the different versions in there. So the application demands like a minimum version of a specific infrastructure component, and that allows a provider and the application developer to very clearly specify if they redeploy like a and even test afterwards if they redeploy a new version of the application, to make sure that this version is still compatible with the same database, or if you update the database, to make sure that, well, the application already supports the newer version of the database. That's part of like the application descriptor files.
And wouldn't you need these data services in the level above as well for, you know, the continuous integration and testing that you're going to be doing there?
Yeah, that's an excellent question. Typically, you do need some kind of the same component. So you, of course, do need a database as well to store your test data or your development data. However, that does not have to live in typically expensive Tanzu data service provided by a service provider. That can, for example, live locally on my laptop or in my development or test environment with a local instance. And that's now the benefit of having the same technology, let's say a Postgres database, in the development part of the lifecycle. So when we look at the upper side of the chart here, that might be some local Postgres instances where I don't care about enterprise readiness or production readiness. So it's a single instance, not highly available, not highly scalable, because I just want to use that during development. And that can run at the beginning from, well, the same Bitnami sources. I can use the Postgres on my laptop, for example. I can use it in the continuous integration environment where automatically being deployed and tested. And then once it comes to production, I can let the application, as part of that descriptor, like switch over to the production service of that Postgres database, which then consumes a managed service from the service provider.
Yeah, that makes sense. So the only thing you'd have to ensure then is that you're using the correct version of whatever is in production that time. Yeah, that makes absolute sense. Okay, and so then that would go into my sort of testing harness around, you know, I'm testing maybe this RabbitMQ, this SQL Server, this application. That would then cycle through that test sequence, whatever the test sequence is defined in something like JRun or whatever it might be. And then that would be where this continuous delivery then kicks in and calls the services to kind of deploy into production potentially.
And that's typically part of the tooling for the continuous delivery or continuous integration, continuous delivery. So as part of, I don't know, Jenkins pipelines, GitLab runners, whatever, you typically have a lot of gating between these different stages so that you have some automation typically for the commit and then initial testing, but then anything that goes into production really has to be gated and made a intentional move by someone. Either think about approval pipelines. Typically it's not some manual approval, but really some very fine-grained or finely specified gating rules to allow it has to be run through the testing, through the security license dependency scanning, especially for open source components. And then I think it's already, it's mentioned in the slides as well. You typically have these strategies for blue-green deployments where you just don't deploy the new application for everyone or for every user, but just carve it out like for a small part for user to deploy or minimize the impact if something goes wrong there.
Yeah. And obviously these days when we're talking about deployment into production and you know, we're also wanting to provide the operational side like you've alluded to there, Gerrit. I think a key part of that is being able to automate that operational onboarding, particularly if there's like, you know, new services, new microservices that are being called, and you want to understand the timing that this code is taking to go through these microservices. And how is that then a part of the kind of infrastructure as code? How does Tanzu observability, service mesh, cloud health, and VROPS, how do these things then pick up those application changes? Or is there any automation that can be applied to that?
Yeah, I mean, this is largely depending on what kind of tool you're using and what you're trying to monitor with that, right? So VROPS, for example, has capabilities for automatic application detection for some components of any given application, probably not for all, really depending on what exactly your stack looks like. There is integration, for example, between TMC and Tanzu Observability and Tanzu Service Mesh. So these can talk to each other and, exchange information about what kind of clusters are deployed and probably even what's living in those clusters. Generally, I would assume that in most cases, there is still some manual work to be done on top in order to ensure that everything is fully monitored and part of the observability strategy. But a large degree of that is automatically detectable, but probably not all of it, really depending on what the application looks like.
So most of the components are auto-detectable. So for example, if a new namespace, if a new application is deployed, TMC, for example, will auto-detect, and observability, vRealize operations can auto-detect as well. And as Garrett mentioned, especially in the application environment, it's quite likely that you have to manually add something to your monitoring capabilities because this is really application dependent and very difficult to auto-detect.
Yeah, that's what I'm trying to understand. So if I've introduced a new microservice, for example, into my application, I understand the ability here to monitor the infrastructure kind of dependencies on that the application has, because that's all Kubernetes and everything else, and we're good at that. We've got that. But if I wanted to then see, this is the new application I've deployed, how long is each microservice taking to transact, and understand where I can make optimizations in the code, for example, is that something that service mesh would give you a visibility into?
Yeah, so service mesh would be the tool of choice to monitor what you just said, right? So what does the communication between microservices look like? Do we have any sort of delay or performance issue in that stack, right? And I would assume that Tanzu Service Mesh automatically picks up most of that, right? But again, this is up for detail, right? Yeah. On the other hand, only from the ops perspective, it again depends on what the microservices that you're deploying looks like, right? If it's a container sitting on Kubernetes with MySQL, VROPS, for example, with the right management packs and application discovery will pick this up automatically. If it's something really, exotic, or you want to deep dive into what's happening in that application, look at specific application metrics that may not be supported by VROPS, for example, you might need to do some manual work or build this on Tanzu Observability. So there's not an easy black or white answer here, really.
Yeah, got it. I think the tools are there, right?
Yeah. To give you some example for that, if you look at like an e-commerce application, like an online shop, that typically has some database backend, and with, for example, VROps through Visibility Suite, you quite easily can automatically detect the number of transactions to the database per time, or their result and their latency. However, it's up to the application developer who has the knowledge how that actually translate to more business metrics, like number of orders that end users do in that online shop, because only they know if an order will result in 20 different transactions or in one big transaction or whatever. So at that level, typically the application developer has to put in some of these monitoring capabilities.
I think this is where it gets interesting, because previous to sort of Kubernetes coming along, it was all about the workload, and the workload had certain characteristics, which meant you gave it certain infrastructure, compute, memory, etc. Capabilities to satisfy the workload, and it was fairly easy to see them when there was problems with that workload, when it was hitting 100% utilization, and diving into a database, you could see where that utilization, or an application where that utilization was being exceeded. And that wasn't really a problem back then, because it could be fixed with code, but you were always paying for this unit of workload, so it didn't really matter. Whereas now, not in this scenario, but in hyperscale cloud, where you're paying per millisecond transaction for the microservice, it's really important for operations to understand how much that application is costing them to do the transaction. Because you could write classic Java, you could write everything in one huge class file that takes half an hour to actually execute, or you could write everything in very small class files, which are much faster and multi-thread faster. This is some of it, I guess, the due diligence you have to work with your developers on. But it's interesting to see that change, and actually now developers are more responsible for their application costs, or should be, than ever before.
I mean, that's the whole purpose typically of DevOps, to bring developers and operations closer together, or even have the developers, typically being part of the operations team, at least for the application, not for necessarily for the underlying infrastructure, but at least for their application.
Yeah. So there is the right tooling here then to do, I mean, this is what I'm trying to understand, there's the right tooling here for us to do absolutely everything end to end, from the core infrastructure that's running the Kubernetes clusters and running all of the OSS packages that are required for continuous integration down into deployment, to that ability then to dive into the application and understand what the components are doing within the application that the developer is responsible for.
Yeah, and I think that also is a very good way to circle back to different business models you could create as a service provider here, based on, well, your own strategy of how much skills for these different components you have in-house, and how generic or specific you want to work together with your customer, with your tenant who owns or runs the application. So for example, you could say, okay, I'm rather like large scale generic provider. I offer, of course, App Launchpad with the Binami catalog. I might offer Tanzu data services in a generic way, but I don't really care about how my tenants are consuming these services. I just run the infrastructure, and that's my business. But on the other hand, and we also have providers, quite a lot of them, that work very, very closely with specific tenants and really build infrastructure for specific applications with their tenants. So that's where operators and solution architects from the service provider work very closely with the developer from the tenant to make sure that they collaborate on the whole lifecycle that we see here, and very specifically build the infrastructure needed for that particular project or application. And then it really can be that the service provider even knows about the application details and can provide, I don't know, observability or VROps dashboards that are very, very specifically catered to that application.
Yeah, I mean, that's a really good point, Jörg. So, as a service provider who's looking at their next generation of portfolio, obviously here is a whole lot of portfolio stuff that you can offer. And it's great because this gives you the diversity of portfolio that your customers need and want. However, if I'm coming from a classic service provider realm where I'm used to managing workloads and infrastructure, a lot of this is going to be foreign to me. So I then may be in that mode, Jörg, that you described, where I just say, hey, fill your boots. Here's all the stuff you need. Go do whatever you need to do. And what we're seeing a lot of providers do is partner with specialist companies who provide things like data lake services, for example. So they are, where the service provider has skills in certain databases where they might have, managed services from before. In this new world, those will translate quite nicely into managed services still for these new databases that you're providing for these new services. But you will be, and it's fairly impossible to have complete coverage of all of the skills that you need for this. We are seeing more and more partners, service providers partnering with application specialists to deliver the application environment that the customer needs.
Yeah, and that's also a super important aspect of differentiating from what a hyperscaler does, right? So I mean, AWS and Google and Azure, they will give you all the tools in the world, right, with all the capabilities that we discussed today. But for our partners, it's important to then figure out where can I put, the right managed services and value-added services on top of observability, service mesh, build service, and so on. And that's actually one topic for one of the other sessions that are coming up on a little bit of the competitive side of Tanzu, right? So how can you build something that's comparable to what a hyperscaler does with those services, and what kind of value adds can you actually put on top. And that's then really a long-term view on how our provider partners can grow, not just in terms of cloud services, but in terms of managed and professional services on top, because that's really their superpower compared to what customers get from a hyperscaler, right? Is providing the right managed services on top.
Yeah, absolutely. So I think there's two things here, right? One is the environment that you're running in. If you are requiring sovereign cloud and your data needs to stay in your national boundaries, then this is a great solution for cloud providers to be able to offer, like you say, Garrett, similar services to hyperscale can offer today, but also then differentiate themselves in managed services. So yeah, there's plenty of kind of scope for understanding where this would be a really good fit. And also the cloud providers today, I mean, they are running the customer's data. So it makes absolute sense for them to kind of expand in this direction and help customers rather than lose that data to a hyperscaler and lose that customer. But let's leave that for the next one, folks, because that's a good place to wrap up, I think. Gentlemen, any final thoughts before we wrap up? All good. All right. Thank you very much, Garrett. Super presentation, mate. That made absolute sense to me. So I'm really pleased that we ran through that. Stefan, Jörg, thanks, guys. Have a great one.
Thanks, everyone.